Good morning. Let's take our next look at our algebra topic. This unit, we've been looking at solving systems, which means two or more equations that we're looking to find the same answer. So we've looked at graphing method, and that's when we look at all of the points make up a line on one equation, all of the points make up a line on the second equation, and we're looking for that one point where they intersect. We talked about substitution, where you have one equation solved for one variable, and then you substitute that equation into the other one to solve. And today we're going to look at our third method, and that's called elimination. So our objectives for today are to be able to solve systems of equations using the elimination method. Now, I'll be really honest with you. This is probably my go-to method most of the time. Not always, but most of the time. Elimination method is not quite as intuitive as to why it works, but it's a really great method to use, especially if equations are in standard form. So let's look at the first problem. It says, what is the solution to this system of equations? So if we're going to use the elimination method, a couple of things have to happen. Number one, we need to have them both in standard form. So if you'll remember, standard form means the x and the y are on the same side of the equation, and what it's equal to is on the other side of the equation. And so these both look like they are in standard form. We've got our x's first, then our y's, equal signs, and then our numbers. The second thing that we are looking for is we're looking for opposite variables. Now, this may seem a little strange, but what I mean by opposite variables is I want an equation in one of the variables in one equation to be opposite the variable in the other equation. For instance, a 2x and a negative 2x, or a 7y and a negative 7y. If I don't have opposite variables, I can still use elimination. I just need to make opposites. And so we'll talk about that here in just a little bit. All right, once I have opposite variables, everything's lined up, I have opposite variables, I'm going to add to eliminate. And then once I have added to eliminate, I'm going to solve, and then I'm going to use substitution to find the other variable. So some of this should look familiar once we have solved. So substitution to find the other variable. All right, so let's look at this first problem. First things first, they are both in standard form, so we'll check on that one. Number two, we're looking for opposite variables. So I first start by looking at my x's. I've got an x and a 2x, not opposite. So then I go to the y's. I have a positive y and a negative y. Those are opposites. So I already have opposites. I don't need to do anything further. And so then it says add to eliminate. So I'm going to put a plus sign out here, draw my line. I'm going to add these two equations together. So an x plus 2x's gives me 3x's. A y plus a negative y cancels out. That's why I say add to eliminate. We're eliminating one of the variables. And then 7 plus 2 is 9. I've now done step 3, add to eliminate. So finally in step 4, we're going to solve a simple equation. So in this case, I'm going to divide each side by 3, and I'm going to get x is equal to 3. So I have my first variable solved for, but remember in a system, we're looking to solve for the x and the y. And so now I'm going to use substitution to find the other variable, which means I'm going to plug that answer in to one of these two equations. Does not matter which, and so I always look for the easiest. And in this case, I think the top equation would be easiest. So I'm going to say 3 plus y is equal to 7. And then again, solving this simple equation, I'm going to subtract 3 and get y is equal to 4. Therefore, the solution to my system is the point 3, 4. I can always check these answers, guys. I can know that I got this one right by plugging those values in. So is it true that 3 plus 4 is 7? That looks good. And then 2 times 3 would be 6, and 6 minus 4 is 2. I can feel confident with that answer. So let's try another one together, and then I'll have you do one on your own. So step 1, are they all lined up correctly? They look good to me. Step 2, do we have opposites? 2x and negative x, not opposite. They are opposite signs, but not opposite numbers. But negative 4y and positive 4y are opposites. So we're ready to add to eliminate. So 2x plus a negative x just gives me a value of x. And negative 4y and 4y eliminates, and I'm left with 2 plus 3 is 5. Guys, this one we didn't even have to solve. We already have our first solution. X is 5. So now to find the next solution, I'm going to plug that value in. Again, it doesn't matter which one. You choose which one you think looks easiest. I'm going to try the second one this time, and so I'm going to get a negative 5 plus 4y is equal to 3. This time I'm going to add 5 to each side because I'm trying to solve for y, and I get 4y is equal to 8. Dividing each side by 4, I get y is equal to 2, and I have my solution of 5, 2. We can always again check that. So 2 times 5 over here would be 10, and 4 times 2 would be 8, and 10 minus 8 is in fact 2. Over here, negative 5 and 4 times 2 is 8. Negative 5 plus 8 is in fact 3. I can feel good about that one. Why don't you take a minute and try B? So I already see that I have opposites on my x's, so I'm adding to eliminate, and I get 5y is equal to negative 5. Dividing each side by 5, I get y is equal to negative 1. Now, guys, this time we solved for y, not x. So when we go to find the other variable, we plug that number in for y. So I'm using the top equation, and I'm going to have 2x plus 3 times negative 1 is equal to 1. So I've got 2x minus 3 is equal to 1. And if I add 3 to each side, I end up with 2x is equal to 4. And divide by 2, and I get x is equal to 2. So again, my solution, don't forget, x comes before y, is 2, negative 1. All right. So I want to take a minute and explore another property that we can do here. So first things first, I want us to think of some values that I could plug in for x and y that would make this equation true. So for instance, probably the first one you think of is 6, 6, because 6 plus 6 is 12. You might also think of 10, 2, because 10 plus 2 is 12, or you might think of 5, 7, because 5 plus 7 is 12. Lots and lots of different possibilities here. All right, here's what I want us to think about. If these are all values that satisfy this equation, I want us to look at what happens if I multiply this equation by a number. So for instance, what if I multiply this whole equation by 2? I would end up with 2 times x, which is 2x, 2 times y, which is 2y, and 2 times 12, which is 24. Now my question to you is, do these same values still work in this new equation that we've written? So let's try it out. 2 times 6 would be 12. 2 times 6 would be 12. 12 plus 12 does in fact equal 24. So this one still checks out. Going on to the next one, 2 times 10 is 20. 2 times 2 is 4. 20 plus 4 does in fact equal 24. So this point also works. And then finally, multiplying 2 times 5 is 10, and 2 times 7 is 14. 10 plus 14 does in fact equal 24. Let's try another number. So instead of multiplying this time by 2, let's multiply this time by negative 1. So negative 1 times x becomes a negative x. Negative 1 times y becomes a negative y, and negative 1 times 12 becomes a negative 12. If you'll check them out, every one of these points still works in this equation. So what I'm trying to say is this, guys, when we have an equation and we find points that work in that equation, The same points work in an equation that's multiplied by a number. Now, it has to be the same number, and we have to multiply all three parts by that same number. In other words, the equation, when multiplied by a number, is just a multiple of that equation, and the same points are solutions to that equation. Why is this important? Well, let's take a look at this next problem. All right, so this next problem, we've got them all lined up. Everything looks good there. I don't have opposites, though. And because I don't have opposites, remember we put that second statement that says, then make opposites. So in this case, I look and I see, hey, I've got 3x and 3x. Those are just the same. They're almost opposites. If I could just make one of those a negative 3x, then I'd have opposites. And so using what we just learned in that last slide, I'm going to multiply this whole equation. That means every single part of this equation by negative 1. When I do that, I end up with a negative 3x, a negative 5y, and a negative 12. And now, if I look at these two equations, remembering everything in this equation is going to have the same solution as this one, I have opposites. So now I'm ready to add to eliminate. So 3x plus negative 3x cancels out. 7y plus a negative 5y becomes 2y, and 24 plus a negative 12 becomes 12. Dividing, I get 2, or dividing by 2, I get y is equal to 6. And now I'm going to plug that value in, remember, for the y this time, in order to find the other variable. So using my top equation, I'm going to have 3x plus 5 times 6 is equal to 12. I've got 3x plus 30 is equal to 12. If I subtract 30 from each side, I end up with 3x is equal to negative 18. And dividing by 3, I finally get x is equal to negative 6. So my solution is the point negative 6, comma 6. So we're not going to do this next problem, but I'm asking you, what would you multiply by to get opposites on this equation? Well, looking at this, there's really a couple of possibilities. 6x and 3x, if I multiply that bottom equation by negative 2, I get 6x and negative 6x. So that would be an option. The second option, if I look at y, I see they're both negative 2y. So I could just multiply either equation by negative 1 to get opposites. Both of those would be good ways to start this problem. All right, so finally we get to this last type of problem. In this case, I can't just multiply by negative 1, and I don't have opposites to start with. So this one I'm going to have to think about multiplying by a number. So when I look at it, I see I have an x and a 2x, and I think, it'd be really nice if that top equation had a negative 2 in front. And so since it's got a 1 right now, even though we don't see that, if I multiply the top equation by negative 2, I can get opposites. So negative 2 times 1x would be negative 2x. Negative 2 times 3x would be negative 6y. And negative 2 times 7 would be negative 14. I've got opposites, and so I'm ready to add to eliminate. Again, for time's sake, I'm going to let you finish that one up. It looks like we should end up with y is equal to 2. And then if you plugged that in, you get x is equal to 1. And so we would have the solution 1, comma 2, if you want to try that one on your own. I'm going to go ahead and skip forward to these problems, because in these cases, it doesn't seem like any way we can get negatives. And so what I want you to consider on this is you may have to do 2 multiplications. You may have to multiply both the top and the bottom equations by different numbers in order to get opposites. So on this first one, if I look at negative 7x minus 8y is equal to 9, and negative 4x plus 9y is equal to negative 22, I can't multiply by 7 by anything and get 4, or 4 by anything to get 7. I can't multiply 8 by anything to get 9 or 9 by anything to get 8. And so what I'm going to do on this one is I'm going to multiply both equations and I'm going to multiply by their opposites. So if I want to make x's opposite in this case, I'm going to choose to multiply the top equation by 4 and the bottom equation by 7, because that's going to get me 28x on top, actually negative 28x on bottom, and on top, and on bottom negative 28x. They were both negative 28. I want them opposites, so I'm just going to choose one to make opposite. It doesn't matter either one. So in multiplying here, I'm going to get negative 4 times negative 7. I get 28x. Negative 4 times negative 8, I get positive 32y. And then negative 4 times 9, don't forget to multiply by that third part. Negative 4 times 9 gets me positive or negative 36. Bottom equation, I take 7 times negative 4 and I get negative 28x. I take 7 times 9 and I get 63y. And finally, I take 7 times 22 and I get negative 154. Guys, these produce much bigger numbers, but still we can solve these problems. And so now I've got opposites, so I'm ready to add to eliminate. So I'm going to take that 32 plus a 63, and I'm going to end up with 95y. And then over here, I've got a negative 36 plus a negative 154, and I end up with negative 190. Solving, I divide by 95 on each side, and I end up with y is equal to negative 2. And then just like before, we would plug that value in to either equation, whichever you think looks easiest. So I'm going to try the bottom equation this time. So I'm going to get negative 4x, and then 9 times negative 2 would be negative 18 is equal to negative 22. I'm going to add the 18 over to the other side, and I end up with negative 4x is equal to negative 4. Dividing by negative 4, I end up with x is equal to 1. So my solution would be 1 comma negative 2. And you can always check that to be sure that you're correct. All right, on this last problem, we won't do the whole problem again, but think about what would you multiply to get opposites? So 2 very good reasons or ways to do this one. I may multiply the top equation by 3 and the bottom equation by 5, and then realizing, I need one of those to be negative. The other option that I have, if I wanted to get y's opposite, is I could multiply, because they're already opposite signs, I could multiply the top equation by 9 and the bottom equation by 4. Either way, either of those options will allow me to find opposites, and then I can add to eliminate. Guys, I hope this makes sense, but if there are any questions or things that you need clarified, please make sure that you stop in and see Mr. Jordan or myself, and we'd be happy to help you out clarifying whatever you've got going on in your mind. I appreciate you and hope you're keeping up with your work. Let us know if we can help. See you later.